Kia ora, hello to the physicists from Whangarei Boys. We know from our work with electric circuits and current that electrons are not used up. They just go round and round. Something must be used up, and what is being used up is energy. And the electrons that are travelling around the circuit act as energy couriers. They carry energy from this place to that and come around and get some more. We'll look at this. So we're going to talk about energy. There's four letters coming up. Energy, E for energy. PE for potential energy. EPE for electrical potential energy. And this last one is a biggie. Electrical potential energy difference. It's a comparison of the energies, which is also called voltage. And that's a big part of our course. Now we're going to use a two-tongued electron taster that tastes them here, tastes them there, and compares the energies. And that two-tongued electron taster is actually an EPED meter or a voltmeter. Now let's look at a little wee imaginary blob. So we've got 48 joules of electrical potential energy in the left-hand side. We've also got 60 joules of electrical potential energy on the right-hand side. And although it's tempting to compare them, so we can see that the 60 joule blob on the right's got more energy than on the left, we need to take in some more information. First of all, the left-hand side's only got 4 coulombs of electrons. The right-hand side's got 12 coulombs. So, although the right-hand side one has got more energy, the left, it's not a fair comparison because we don't have even amounts of charge. So we need to compare them more fairly. To do that, well, we look at how many joules are on each coulomb. Well, on the left-hand side, we've got 48 joules on 4 coulombs. On the right-hand side, we've got 60 joules on 12 coulombs. And using our primary school mathematics, we know that there's 12 joules on each coulomb on the left-hand side, 5 joules on each coulomb on the right-hand side, and then we can do a comparison with the electrical potential energy difference meter, or joules per coulomb meter. So we got 7 joules per coulomb, because it's 12 minus 5, of electrical potential energy difference, and the D is a biggie. 7 volts of voltage. But we can see that volts do not go through things. Voltage is a comparison between two things of different energies. I'd like you to make the simplest possible circuit, and where's my one? I've got one here somewhere. Here's my one here. Let's move this back out of the way. We don't need that just for now. And we're going to measure 2 voltages. We're going to compare the electrical potential energy in 2 places twice, so this side and this side. To do that, we're going to use one voltmeter, electrical potential energy difference meter. And the cool thing is about voltmeters, you don't have to put them into the circuit, you can just touch them in 2 different places. So, like a cooking show, here's one I prepared earlier. So here's my voltmeter, and I'm going to touch the copper wire there. And I'm not going to do it there, but you are. Then I'm going to move this down here and touch it here, and you are as well on your one. Then, so you're going to be looking at 2 voltages in 2 different places, so we can get that measurement, that pair of measurements. Then I'd like you to email me to tell me what words go in this little gap in here. The energy given to the circuit by the power pack is related to, greater than, whatever, I don't know. The energy used by the light bulb. Actually, I do know, but I'm not saying. That'll do for us today, guys. We're just learning this basic stuff to get the foundation from which we can build our knowledge further.